Hello students, welcome to analysis of indeterminate structure class. Last class I gave you one homework problem. Now I will explain once again that homework problem. The problem is analyze the continuous beam shown by slope deflection method. Support B sinks by 8 mm. Support B sinks by 8 mm. Take EI value is 15,000 kilonewton meter square. Here, what is the difference between last problem and this problem? Here, support B sinks is given. Sink means the support B is settled 8 mm compared to other two support A and C. Support B is settled or sink 8 mm. Okay, this is the problem, here given the line diagram, you can observe the support A is simply supported and B also simply supported, and support C is fixed support, and the AD span is the overhanging span, and at the edge of D, at the point of D, point load 20 kilonewton is given applying, and in the middle of span AB 150 kilonewton meter moment is there. It is not a force, it is moment. Okay, it is here directly moment given, and on the span BC UVL is given. It means uniformly varying load is given. The load value is 25 kilonewton meter, 25 kilonewton per meter. Okay, this is the given figure. Next, the solution for this problem is, here settlement is given, no? The support B is sinks 8 mm. Then how you are going to take, what is that 8 mm means? That is the sink. Sink means that is the dou. We already discussed about this. If the sink is given, the settlement value is given, that consider the notation dou. Okay, here, okay, in the support B sink 8 mm is given, but how to take this value in formula, or how to substitute this value in the formula? This is very important. You can observe here, if the support, you can once again you can write this line diagram. Here don't consider any load, just take the sink, just take point B sink 8 mm. Here graphically, this figure is not to scale, here approximately wrote like this, because of here the joint B is sink 8 mm and remaining joint A and C not synced. Okay, here how you are going to take the dou value? It is very simple. Considering the joint B towards left side, consider positive sign, and towards right side consider negative sign, and that consider as a dou value, that is 8 mm, and you can convert into meter. It is 0.008 meter, and towards right side dou is equal to minus 0.008 meter. Okay, now it is clear. After, what is the first step in the slope deflection method? Calculating fixed end moment. Take one by one span. Span AD, if we are going to take first one, span DA or AD, whatever, DA, here the DA span is overhanging span. So how you are going to calculate fixed end moment? You can directly take the load perpendicular to distance at point A. That means moment AD is equal to 20 into 2. 20 is the point load and 2 is the perpendicular distance. Then you are directly getting the moment. that is 40 kilonewton meter. Here you can remember the sign convention. Clockwise, if the clockwise resisting moment, take positive sign. Okay, positive sign for moment. Next, calculating fixed end moment AB or BA, both are same, AB or BA. Here the formula is, here the load condition is directly given moment here. So how you are going to convert this moment to fixed end moment? Here given, directly take m by 4, m by 4, that means moment by 4. The sign convention is positive because of the moment direction is clockwise. Okay, so positive, the moment is given 150 kilonewton per meter, so you can directly take the value 150 divided by 4 and you are getting the answer 37.5 kilonewton meter. Okay, next, fixed end moment BC. How we are going to calculate fixed end moment BC? It will depend on the load condition. You always refer the load condition, what type load is there, and we have the according to the load condition formulas. You can directly take the formula and substitute the given data and calculate. Here the load condition is given uniformly varying load. The value is 25 kilonewton per meter. So the formula is for calculating fixed end moment for UVL is minus WL square by 30, and for CB is plus WL square by 20. You can substitute the value here. W is the given uniformly varying load 25, and L is the span. L is the span of the BC, and calculate the answer. You are getting minus 20.83 kilonewton meter, and fixed end moment CB is plus 31.25 kilonewton meter. Okay, the first step is over in this problem, calculating fixed end moment. Next is slope deflection equation. Now next step is apply the slope deflection equation. Here theta c is equal to 0 because it is fixed. Theta c is fixed, so here theta is 0. For overhanging portion, do not write slope deflection equation. Okay, this also we discussed last problem. And so directly you can take span AB. Therefore moment AB is equal to the formula here taken directly. Okay, actually you can once again write the formula, full formula, after you can substitute. That practice you should make habit, because then only you are not forgetting the formula. When you can writing again and again, it will permanent in your mind like that. Okay, here I skipped that formula step. That means once directly I substituted the values. Here in the place of EI, in the place of Young's modulus and the I value here given in the problem, EI value is 15,000 kilonewton per meter square. You can directly substitute the value here. Okay, and remaining part theta A and theta B is equal to 0, so you can keep it as it is, and remaining part is here. See, yes, here 3 dou, what is the formula? 3 dou by L. That means here dou value is for AB plus 0.008. So that value here substituted, nothing else. Okay, divided by the length. L is 4 meter. It is correct, no? Yes. And plus fixed end moment AB. We already calculated. You can substitute the value here directly, and solve this equation. Finally you are getting this equation number 1. Similarly for moment BA, okay, and you are getting this equation number 2, and similarly for moment BC, here also you can getting the equation number 3. Here in the span BC you are taking theta B and theta C. Theta C is equal to 0 because the support is fixed support. So here you can consider directly 0. Here only one unknown theta B. Remaining next is the, similarly you can calculate moment CB. Moment CB is you are going to calculate the equation. You are simplify the equation and you are getting equation number 4. Okay. Next